Now, 17 through 27, we're going to start using Ohm's law, which is V equals I times R. Voltage equals current times resistance. So number 17 is kind of giving us kind of acclimated with Ohm's law. It says the ratio of the potential difference across a conductor to the current in the conductor is called what? And so if we just break this down, we're going to translate this English into mathese or math language. And so the ratio is a fraction. So we're going to make a fraction of what? We're going to make a fraction of potential difference, which is our voltage. And so I've written a green V above that, and then current, which is an I. So we need a fraction of V over I. And so I've written that here. This purple arrow is just translating all of that English into a simple little math phrase, V over I equals question mark what? Now to solve this, I need a connection with V and I in it, and that connection is Ohm's law, V equals I times R. Now I need to make it look like V over I, and so what I'm going to do is I'm going to divide both sides by I. There we go. I is going to cancel on the right, and I have V over I. And what am I left with on the right side of the equation? I'm left with R, and so what I see here is actually that V over I is equal to, it's no longer a question, it's equal to R. And what is R? R is resistance. So then I can come back up here and I can circle in B as my answer. Okay. Ooh, look at all this writing here in number 18. Number 18 is going to be an example where we have to work with literary equations, working with those letters again. And so it says when the total resistance of a simple electrical circuit is decreased while keeping the voltage constant, the current in the electrical circuit will do what? Decrease, increase, or remain the same. And so we're going to put in Ohm's law because we see resistance, voltage, and current. So we see resistance R, we see voltage and current, and so we need to relate those and see what's happening. And so V equals I times R. Now I'm going to lock V in a box here. Boop, 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 boop. So it's locked in a box. It has to stay the same as I've written there in pink. And then I'm going to draw arrows to show what's going to happen. And so they're telling us that the total resistance is decreasing. So I have an arrow pointed down showing that. And then if you can work with it in your imagination, if you can imagine that V needs to stay the same, if R gets smaller on the right, then I would have to get bigger, and so I'm showing that with this arrow up, in order for them to multiply and still get the same number. If you can't imagine that yet, if you're still working on that, that's fine. You might want to resort to an example of numbers. Pick some of your favorite numbers, put them in, and see what happens. And so here I have an example. Let's just say that we're working with some kind of 10-volt power source, and so the voltage is going to be 10. And so I'm going to have two situations. The top one says 10 volts, the bottom one says 10 volts because they have to stay the same. And then I'm going to start, I'll just pick a number for my resistance, and I've picked 5 ohms. So let's say I have a resistance of 5 ohms to start with. What would my current, have to be? Well, 5 times what equals 10? 5 times 2 equals 10. So my current would have to be 2A, 2 amps. Now, drop that resistance for your second example, because they said resistance is going to get decreased, it's going to get less. So let's drop that 5 down to a 1, and that's what I've done here. I've said, well, let's say 1 ohm. So 1 ohm times what would have to equal 10, and 1 times 10 equals 10. So then I know that my new current would be 10 amps if my resistance dropped from 5 ohms to 1 ohm. And so what did I see? I saw 2 become 10, and that meant that my current went up. In fact, the current went up proportionately. My resistance dropped by 5 times smaller, and my current went up by 5 times larger. 2 turned into 10. Okay, so that's an example of numbers, and it's often helpful to even veteran physicists. Now, you're going to use VER for 19, 20. Here's examples of where you're getting your numbers from, and 21, 22, and you can see that you're going to need to rearrange VER a little bit there in number 22. Let's go on looking at 23, again rearranging VER, getting comfortable with that. And you can pause the video at any time you need to, see where I'm circling things, getting numbers out of these questions, and then looking at the equations. You can pause the video